Let's look at question number 4. It says do not use calculator in answering this question, so we have got to do it manually. Three complex numbers z1, which is given as 1 plus root 3i, and z2, which is given as 1 minus i, and z3, which is of course given in with the trigonometric functions of 2 cosine of 1 6 pi plus I sine 1 6 pi. So if you wish, you could change it to a rectangular form and then do. Right, but I'm not going to do all of that. So the question says find z1 over z2, z3 in this form. Okay, so how are we going to do it? First, we're going to find out what is the magnitude of the complex number z1. So the magnitude would be simply, of course, to use the Pythagoras theorem. So it's going to be 1 squared plus square root of 3 square of root 3 square of root 3. So I'm having a little bit of tongue twisting. So now this is actually equals to 2. Why? 1 squared is going to be a 1, root 3 squared is going to become a 3, 3 plus a 1 is of course going to become 4, and when we square root the 4, it would become a 2. So now similarly, let's work out the magnitude of z2. z2 is a 1 and a minus 1, right? So it's going to be square root of 1 squared plus minus 1 squared is of course going to become also positive number. So 1 square is a 1, minus 1 square is also a 1, 1 plus a 1 is going to become 2. So this will be magnitude of z2 will be simply square root of 2. How about magnitude of z3? Okay, magnitude of z3 is already given to you straightforward here. So there is already a 2 here, so that is the magnitude, right? And of course from inside we can get the arguments. So now let's work out similarly the arguments of z1. Okay, the argument of z1, we would take the arctangent of, okay, the imaginary components coefficient, which is negative root 3, and divide that by 1, and this is of course a special angle. Arctangent of root 3 is simply going to become pi over 3. So there we have the argument of z1. Now we're going to go for argument of z2. You can see it's a 1 1. So, and we can see this very readily that this is going to be a negative value, because minus 1 over 1, that's a fourth quadrant answer. So arctangent of negative 1 is going to be a 45 degrees or negative pi over 4. So this is a fourth quadrant value because we need to consider the argument from negative pi to positive pi. So therefore the argument of z2 is minus pi over 4. Now let's look at the argument for z3, which of course you don't have to do much, it's already given to you. So it is simply pi over 6. So there we have the arguments of z1, z2 and z3. Now we can simplify and find out what's the value of z1 over z2 dot z3, right? So what would be the magnitude of z1 over z2 and z3? That means let's find the magnitude of this. So we can use the individual magnitudes to actually calculate magnitude of z1 over magnitude of z2 times magnitude of z3, okay, on the denominator. So magnitude of z1 is of course a 2, and then we divide it by magnitude of z2, which is going to be root 2, and multiply by 2. So the denominator would become 2 root 2. We can cancel the 2 and the 2, and that's going to give us 1 over root 2. And of course if you rationalize it, then by multiplying the numerator and denominator by root 2, so it would simply become root 2 over 2. There we have the magnitude of this complex number, right? Now let's work out the argument of this complex number z1 over z2 dot z3. So arguments is similar to how we perform logarithms, right? So argument of the numerator, then subtract away, okay, the arguments of the denominator. So minus argument of z2 minus argument of z3. So this is how it becomes. So now let's take each and every one of the arguments, since we have already calculated the arguments of each of the complex numbers. So let's throw them in. Pi over 3 is the argument of z1, and minus pi over 2 is the argument of z2, and pi over 6 is the argument of z3. And when we substitute there and we simplify it, it's going to become 5 pi over 12. That's going to be the argument for this z1 over z2 dot z3. So what would be the value of the complex number z1 over z2 z3, which is the magnitude, which is root 2 over 2. And since the question wants us to write it in trigonometric form, so cosine, and of course we have the argument found from this first part, which is 5 pi over 12 plus I sine 5 pi over 12. So there we have z1 over z2 dot z3 in the form as requested by the question for 4 marks. Now let's take all these values, and the next part of the question says find the possible values of z4, right, in this form. Now a fourth complex number z4 is added on to the first part, which we have already calculated, which is z1 z2 z3, okay, and multiply that by z4, and you are told that when you perform this, it becomes purely imaginary. Okay, purely imaginary means there is no real part of it, and you are also given that the magnitude of this complex number, right, is equals to 1, and we are supposed to find what are the possible values of z4 in this form, where r must be of course positive, and the value of the argument, which is theta, must be between minus pi to pi. So let's now work it out. z1 z4 over z2 z3 magnitude, it's going to become, I could split it up like this, z1 magnitude z1 z2 z3, because we have already done it in the first part. There we have the answer, and of course we can multiply that by z4, and we are told that this one's magnitude is of course a 1, right? We are already given in the question. So this part's magnitude is root 2 over 2, and what we do not know is the magnitude of z4, so I'm just keeping it as it is. And for the left hand side, since we are already given it is equals to a 1, so I'm just putting in the 1 there. So all we need to do is now to rearrange by cross multiplying the root 2 over 2 to the other side. So 1 times root 2 over 2 would become 1 divided by root 2 over 2 is going to simply become root 2. Okay, and of course you can simplify and find it yourself. So the magnitude of z4 is therefore equals to square root of 2. Now what about the argument? Okay, so argument, of course we can also split it up in the same way, and I can just split it up as z1 z2 z3 together as one single complex number, and z4 as another complex number. But since it is a product, so we're going to add the arguments together. So that would be plus argument of z4, and you are told that this is purely imaginary, right? So if it is purely imaginary, right, so what does it actually mean? Okay, the cosine component, okay, is going to become 0. So what value of the theta will the cosine become 0? Of course cosine 90 degrees is what that's going to give you 0, so as not to have any real part, right, so that it can become an imaginary part. So for that, the argument of this particular complex number should become pi over 2. Okay, that should be the argument. And since we already know this argument based on this word is purely imaginary, is definitely supposed to be pi over 2, now we can substitute. Of course the other value would be, what is the other value? Okay, of course 270 degrees, or it can be 3 pi over 2. So for this also is going to be purely imaginary. Therefore now we can say argument z1 over z2 z3 plus argument of z4 should be equal to pi over 2. If this is the case, we already have the argument of this, and we can replace it with 5 pi over 12 in the next step. But since we have an or here, so let's do that part as well. Argument of z1 over z2 z3 plus argument of z4 should be equal to 3 pi over 2. So let us evaluate the values of argument of z4 in each other case. Argument of z1 over z2 z3 is 5 pi over 12, which is obtained from the first part, and I'm just putting it here, plus let me just copy down the argument of z4, and this is pi over 2, or this value could be 5 pi over 12 plus argument of z4 is equals to 3 pi over 12, right? So now these values, if I solve this equation, I should be able to get both values for argument of z4. Therefore your argument of z4 must be either pi over 2 minus 5 pi over 12, which would become pi over 12, or if you solve this part of the equation, it should be argument of z4 should be minus 11 pi over 12. So there we have the two possible values of the arguments, and since we have all the values already, so now we can write down the complex number z4. So the magnitude is root 2, so we're going to write the root 2, then cosine of these are the arguments for the z4. So of course we write the first one, which is pi over 12 plus I sine pi over 12. So that is one possible values of z4, or the other possible values of z4 should be, okay, square root 2, which is the magnitude, times cosine of negative 11 pi over 12 plus I sine negative 11 pi over 12. And there we have two of the possible values of z4 in the form as required by the question. Okay, so that's why there are two values, as you can see from the question itself.